Hi everyone. We have come to the second part of chemical bonding. Okay. The first part we learned about ionic compounds and how to draw dot and cross diagram. This is part two. We're going to learn about a different kind of bond today. Okay, just let's do a quick recap. Okay, we started out with bonding. We learned about ionic bond. And what is ionic bond? Basically, a bond between metals and non-metals, right? Okay, the metals will lose their valence electron, and the non-metals will gain their valence electron. Okay, and what is the purpose of forming bond? Is to achieve a stable electronic configuration. Okay, or you can also say noble gas configuration, but it's the same. Okay, today we're going to look at a second kind of bond, which is known as covalent bond. There is no N, so please do not write convalent. It's just covalent. Co means there's going to be two or more. It's not going to be metals. You will know in a while. Okay, this is the learning objective. We're going to learn what is a covalent bond, how is it formed, and of course, like ionic compounds, we're going to draw a dot and cross diagram. Okay. Okay, this is covalent bond. The bond is between non-metallic elements. Sorry, non-metallic elements. Okay, and they do not lose or gain. They will share electrons to attain a stable electronic structure. Okay, and the sharing of electron is the covalent bond. Okay, so in your syllabus, you just have to know how to draw two non-metals. How do they share in the cross and dot diagrams? Okay. Okay. What do they share? Okay, like what I said. They want to achieve a noble gas configuration. Noble gas is all your group 8. They're all stable, right? Okay. So they want to achieve a noble gas configuration. Okay. And when they share, they should get 2 or 8 electrons in the valence shell. Okay, like for hydrogen, not enough. When hydrogen don't have too many electrons, so basically 2, and the rest of it will be 8. Okay, so I'm just going to talk about the non-metals. Okay, hydrogen. Okay, okay, and let's look at the first example. Okay, hydrogen. Okay, as an atom, H, it has 1 electron, right? Okay, 1 dot. You can see 1 dot. And when it combines with itself, another atom with a cross, and then they will share electrons. And now it has 2 and 2 become stable. This is known as a hydrogen molecule, or you can call it a hydrogen gas. Okay, as just H, it's not stable. So you'll combine with another H to form a stable structure. Okay, this bond you see here is your covalent bond. Okay, this is another way of showing. This is a structural diagram. This is a cross and dot. So if there is 1 dot and 1 cross, you denote by 1 line. Okay, and this is known as a single bond. Single covalent bond. Okay, that's for hydrogen. Okay, very simple. Okay, let's look at more examples. Okay, I'm going to show you a couple of examples with double and triple bond itself. Okay, this is what I said. So this is known as a molecule. Okay, no more, it's not an atom anymore. Okay, I hope you know this. Okay, let's look at fluorine. Fluorine, if you look at fluorine, look at your periodic table. Hope the periodic table is with you. Fluorine has 9 electrons in total. So when I write my electronic configuration is 2.7, so it is in group 7. Okay, your valence electron gives you the group number. We learned this in the topic before this. Okay, 7 electrons, 1 fluorine atom. Okay, another fluorine atom. There's also another 7 electrons. So we denote by a dot and cross, so that it's easier for you to see. So when they combine, okay, they form this. Okay, when you draw covalent, can you please ensure it is inside this overlap, your dot and cross, and not on the lines, okay? And you don't need to necessarily draw the inner shells, okay? When we draw covalent compounds, we only draw valence electrons or shells, okay? And this is the shared electrons in the overlapping region, okay? So FF is a single bond because you saw earlier there is, maybe I backtrack, there is a cross and dot. So as long as there's one cross and one dot, you denote by one line. So this is the bond, covalent bond between FF, okay? So this is fluorine gas. Fluorine gas. I'm not asking you to draw atoms, it becomes a molecule. Okay, okay, let's try oxygen. If you look at the periodic table, oxygen has how many electrons? 8 electrons in total. So when I write electronic configuration, it's 6 electrons. So you can see 6 dots and 6 crosses, right? Okay, as an atom, not stable. I want to make it stable. It will combine. Okay, you need to bring, can you look at this? So probably this two and this two. Bring it to the center. So you can see this. The 2 crosses and 2 crosses come to the overlapping region. And then you count this. This has 4, 5, 6, 7, 8 in the valence shell. Here also 4, 5, 6, 7, 8, 8 in the valence shell. So it's stable. So since there is 4, 1 dot, 1 cross, 1 dot, 1 cross, we denote by 2 lines, and it's known as a double bond. Okay, so oxygen gas has a double bond. Okay, this is one of the molecule that's quite common. Okay, so it's like 2 hands. You can see, got 2 hands joining together, so there's 4 electrons. Okay, let's look at triple bond. This is my nitrogen gas. So nitrogen, very classic example. Okay, if you look at one nitrogen atom, it has how many electrons? Okay, maybe I just use electronic configuration. Not electronic configuration, the valence. It has 5 valence electron. Okay, so I'm going to quickly draw here a big one. So I'm only just going to draw the out valence electron. So cross dot, another cross dot. Okay, not enough space, so you can see 6 sharing. Okay, 5 electrons. You can see 1, 2, 3, 4, 5 crosses for this nitrogen. 1, 2, 3, 4, 5. 5 dots for this nitrogen. So it becomes 6 plus 2, 8. 6 plus 2, 8. So it's a triple bond. So there is 3 crosses and 3 dots. Okay, so this is a triple bond. Okay, this is another example. This is another example. You can see hydrogen combining with water. Sorry about my son, okay? Okay, you can see this is oxygen. It has 1 electron, so it's going to combine with this because got 6 valence. So this dot will combine with this. Okay, so you just have to move. Okay, the overlapping region, and then when I draw the structural diagram O, there's 1 dot and cross or 1 line like this. So this is your H2O. Okay, this becomes a H2O molecule. Okay, okay, let's do a quick check one. Which of the following pairs do the elements form a compound by sharing electrons? Okay, sharing electrons only happens between non-metals, right? So this is a metal, this is a metal, right? So option B and D are out. Okay, look at neon. Neon is a non-metal, but neon is in group 8. So it's very stable. So it does not bond. Do not bond. So the only option is this, A. Okay? Okay. We learned about writing formulas for ionic compounds. Okay? Ionic compounds, we do crisscross. Okay, so quick recap. If it's going to be ionic, okay, for example, if I have sodium plus oxygen is group 6, so add 2 more. I will do a crisscross. So sodium oxide looks like this. Crisscross the charges. Okay, but for covalent, we don't do crisscross. So maybe you want to down no crisscross because there's no charges, right? So they will have all these prefixes in the names like mono, di, tri. Mono means one, di means two atoms, tri, three. Okay, there's a missing. This is penta. Penta means five. Okay, you don't have to know so many. So probably this three is more than enough. Okay, so let's look at some example. You see carbon, carbon, carbon. Di means two. Oxide comes from oxygen, so O2. So it looks like this. Okay. Similarly, di-nitrogen, that means there's two nitrogen. Monooxide means one oxygen, O. So it looks like this. Okay. Tetra means 4, it looks like this. Sulfur dioxide looks like this. These are some ways you can see covalent compounds. Okay, there are others. You need to memorize those. These are quite common. Okay, the common ones to draw dot and cross will be this. Okay, methane is CH4. Okay, this is another common one. They can ask you to draw dot and cross. Okay, ozone is your layer that protects us from all the harmful rays. Is O3. Not so common. Okay, ammonia gas is common. Hydrogen peroxide, not so common, is H2O2. It's not H2O. And of course, our water molecule is quite common, right? Okay, let's do a quick check too. This is going to be your work for today. Once I end off end of this pre-recorded lesson, you can take a piece of paper and draw. Chlorine gas, okay, is Cl2. Okay, it's not an atom. Hydrogen chloride, so HCl. Carbon dioxide, CO2. Ammonia is between nitrogen and hydrogen. Just now we saw NH3, and methane is CH4. Okay, you're going to use all these formulas to draw for me a dot and cross diagram. Okay, just draw valence electrons only. Okay, I put here draw valence electron only, so you don't have to draw all the inner shells. Okay, we don't want it to look a bit messy. Okay, that's your homework. So before you come back to my next lesson, this should be done because I think the recorded video, it's about 20-25 minutes. So you can use the rest of your lesson time to complete this drawing. There's only 5. Okay? Okay, let's do a quick summary in conclusion. Okay, this is between metals and non-metals, covalent between just non-metals. I hope you know where your zigzag line is in your periodic table. Okay? And then transfer of electrons means metals will lose, non-metals will gain, right? Okay, and the last one, for not last one, for covalent, they share their valence electron. Okay, and they form ions. Okay, because there's positive and negative charge. And this one, they form molecules like H2, H2O, C4, they're all molecules, etc. Okay, this is where I'm going to end off. So you have work to do. So please ensure this is drawn. Okay, I'll see you next lesson in a Google Meet. so that we can address some of the issues, your misconception in drawing cross and dot diagram for covalent compounds. Okay, thank you.